I can't do any more. Sturf. It's time for bed. This aluminum foil blanket is so thirsty. This is terrible. Yes, that's so much better. Num 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 nums. Num nums. What's going on, people? What's going on, guys? Why is an aluminum foil not a good blanket? Because it has no trapped air in it. What a good insulators have in common. That's it. Trapped air, pretty much. Why is that? Well, if you look at all the gases that make up air, each of them have low thermal conductivities, which of course, low thermal conductivity means it's a... That's right! Low thermal conductivity means it's a poor conductor, which then means it's a good insulator. So all of these gases that make up air, which have low thermal conductivities, actually, what kind of R values would they have? That's right! High R values. So good insulators have low thermal conductivities and high R values. And so all these gases that make up air have low K values, low thermal conductivities, and high R values. Yeah, so trapped air is a good insulator. Where can you find that in the natures? Well, look at some examples here, some common household fixins. Towels, which are, I use as blankets. I mean, bed sheets, right? That has a little trapped air in between all the fibers. And why, like, fluffy sheets and blankets and whatnot are warmer than, like, real thin ones, and ones that when you hold up to the light, you could see through them. So that, like, even, look, cardboard makes a great blanket. This is called corrugated, meaning it has those channels in there. Well, what's in those channels? What gets trapped somewhat in those channels? Air. Sponge. Real sponge is living organic matter. This fake sponge like this is just like a plastic, pretty much like a very flexible plastic. And what's in between? What's in all those little pockets? What am I squishing out? That's right, air. There's a lot of trapped air in sponges. Get the flurfy cotton, squishy. What's in between? All the fibers, cotton fibers. Trapped air. Trapped air's in them. When you compress it, what are you squeezing out of it? Trapped air. Legit, like real foam board, polystyrene foam board that's used in actual homes and buildings and what have yous. Same deal. Tiny holes. And what's trapped in there? Well, you could squeeze, you can compress it, right? So what am I squeezing out? How am I able to compress it? Because there are pockets of air in there. Check it out. Check it out. This is called a cryo cuff. This is just the thermos part with a portion of it cut out so that you can see what is in the walls of like a thermos, of a cooler, at least the ones that aren't vacuum insulated, like your hydro flask. So yeah, you can see there's foam. Look at that rad foam. That's so cool. That is so cool. Trapped in there in between all the little foam holes. Air! Trapped air! And that's what makes this layer of foam such a good insulator, because it has a lot of trapped air in it. What's even better than this? Trapped nothing. Vacuum stuff. Vacuum insulated, like your hydro flask. Everybody loves your hydro flask. I do. Mine's not a hydro flask. I don't care about the environment. I really do. This is vacuum insulated. Windows, some vacuum insulated windows are like double pane windows. Have, double pane means 2 layers of glass, and in between those 2 layers is often just like a gas, air. But the more expensive ones and the more effective ones have, nothing between those 2 panes of glass, just a vacuum. They're vacuum insulated panels that are used on buildings primarily as, there you go. It's a panel of layers of material sandwiching a layer of, nothing, a vacuum. And so what makes vacuum an even better insulator is because Is conduction possible in a vacuum? Is convection possible in a vacuum? The only method of heat transfer that's possible through a vacuum is radiation. So only one out of the three, because no conduction, because no solids in it. No convection, because no liquids or gases in a vacuum. So only radiation. So that's what makes vacuum such a great insulator. And that's why on your list of K values, you see it has a K value of 0. That is like the best, man. So good. Let's wrap this up.